Hello everyone. As discussed in the last class, on the solution of a homogeneous recurrence relation. Now, today we'll talk about the solution. It's the particular solution of a recurrence relation. The detailed description about the method of undetermined coefficient we discussed in the last class. And now today we are having some of the example so that you can understand them in a better way. So if you remember, there are two basic cases. One is beta power n and another is the polynomial of degree k. And the other extension is what? Their combinations. So we are having these four examples. Let us talk about them one by one. The question number one, if we can like relate it with the last class constraint, it is the case of beta power n. The case number one, this is a polynomial, case of polynomial. This is also beta power n. This is also the case of beta power n. This is the combination of two, that means beta power n plus a polynomial. Okay, so on the basis of this Fn, we will firstly try to write the trial solution, and on that basis, we will try to find the final particular solution. Okay, so let us talk about the example number first. The first thing is what we are supposed to write the trial solution. So let the trial solution of the first, let the trial solution of the first an is equals to, it is 2 power n. It will be written a into beta power n. Do remember this constant will not be considered when we are writing the trial solution. Okay, so let this is the trial solution of the given equation first, if I make it as first. Now, one more point that we need to take care, if you remember, your beta should not be the root of your homogeneous equation. Okay, so here beta is 2. Now, if I see the homogeneous part, so the what will be the root of this equation? So if we make the homogeneous for equation for this, it will be r square minus 6r plus 9. This is the homogeneous equation, and I think the root comes out as 3 comma 3 because it is r minus 3 whole square. Okay, so beta is not the root of this equation. So suppose that if in place of this 2, the beta is 3, that means it is given as 3 power n. So in that case, 3 is the root of the equation. So this trial solution need the modification by multiplying it by n to the power 2, that is n square. But here, your beta is not there in your homogeneous solution. So no need to worry. This is your final trial solution. So now put this in your equation number 1. So put this in equation number 1. What will happen? The first term is a n plus 2. This is in terms of y. So better if we are writing the trial solution also in terms of y. So it's not matter that it does not matter that whether it is given in terms of y, a, x, or in some other variable. It is just notation. So what I did, this is our trial solution. So we are supposed to find the constant a. This constant we call as a undetermined coefficient for this problem. So put these terms in the first equation. The first is yn plus 2. We do have the value of yn. So what will be yn plus 2? In place of y, in place of n, put n plus 2. So here yn plus 2 will comes out as a into 2 power n plus 2. Okay, a into 2 power n plus 2. That means replacing n by n plus 2. The first term will be a into 2 power n plus 2 minus 6 times n plus y of n plus 1. So now in place of n, we are supposed to put n plus 1. So this will comes out as a times 2 power n plus 1. The last term is 9 times yn. Yn means as it is this term. So a into 2 power n. It is equals to 3 times 2 power n. Now, as I already told you that we are supposed to find the value of a by comparing the coefficient of 2 power n. Moreover, when we are doing the simplification of this left side, just take care in your mind that it should comes out as the right hand side. That means what? The right hand side is what? 2 power n into something. That means when we are simplifying the left side, it should also be in the same nature. That means 2 power n into something, so that the comparison can be done easily. So what I'm doing, take 2 power n common out of this all terms. The first term is a into 2 power n plus 2. So 2 power n plus 2 can be breaked as 2 power n into 2 power 2. This is comes out what left inside 2 power 2, which is 4, minus from this term it is 2 power n plus 1. So if I break 2 power n plus 1, it looks like 2 power n into 2 power 1. It is common outside, what left? Only 2. So 6 is this one, a is this one into 2, so it makes 12 of a. The last term is 9 times a, and it is equals to 3 times 2 power n. Simplify. So 9 plus 4, 13. 13 minus 12 is 1. So we get it as 2 into a, and it is equals to 3 into 2 power n. Compare the coefficient. Compare the coefficient of 2 power n. So the left side is having coefficient as a, and the right side is having coefficient as 3. So the constant a comes out as 3. Now what should I do? I'm supposed to put it in second for final particular solution. Put a in equation number 2. So now I will not write it as yn, I will write it as ynp. The particular solution of the given equation. In place of a, it is 3. So 3 into 2 power n. 3 into 2 power n. And this is the final particular solution for the given non-homogeneous recurrence relation. Okay, so what we did, let us see once again on the basis of your FN, we decided that what should be the trial solution. Now substitute this trial solution into the given equation. Once you substitute it in the given equation, simplify your equation as per the right hand side so that we can do the comparison easily. Once simplification done, do the comparison to find the undetermined coefficients. Whatever undetermined coefficient is obtained, put it in the given, put it in your trial solution, and the trial solution is converted into the final particular solution. Okay, so this is how we can find the particular solution of example number 1. Now let us take about example number 2, or before that example number 3. So in example number 3, why I'm taking third first? Because it is also beta power n. So over here, your trial solution an will looks like 3 power n. Let your trial solution is 3 power n. Now we are supposed to make it as independent from your homogeneous solution. So what will be the root of the homogeneous equation here? It will comes out r square minus 9 equals to 0. So r comes out as 3 and minus 3. So your beta is present in your homogeneous solution too. Your beta is the root of the characteristic equation too. So we will modify this trial solution since 3 3 is the 3 is the root of the recurrence relation. Since 3 is also the root of the recurrence relation, so we will modify this trial solution. And let us see how we will modify this trial solution. The modified trial solution will looks like n to the power 1 into 3 power n. Why n to the power 1? Because 3 is the root one time. It is 3 and minus 3. It's not 3 and 3. If it is 3 and 3, so we will multiply by n square. So this is your modified trial solution. This is your modified trial solution an. So do remember this thing in case beta is the root of your homogeneous equation, you are supposed to modify your trial solution. Let us make it as equation number 2. Put it in the given equation. So it into put it into given equation. Put it into given equation. Why we are putting it in given equation? Yeah, we forget it to write the undetermined coefficient A. Yes, it must be there. Huh? Otherwise, what we are calculating? So A into n into 3 power n, this is your trial solution, and we are going to put it in your given equation. So let us see what will happen. The first term is yn plus 2. So y, so trial solution should also be in terms of y, not in terms of a. So let us make it as correct, not a, it should be as y. So your trial solution is this yn. Why I am repeatedly write an? Because most of the time it is written as an, the terms of a sequence. So putting it in the given equation, the first term is yn plus 2. This is your yn. So in place of n, put n plus 2. So the first term will be a into, this is n. So in place of n, we are supposed to put n plus 2 into 3 to the power n plus 2 into 3 to the power n plus 2. This is your yn plus 2. This is your yn plus 2. That means what I did, I simply replace n by n plus 2 minus the second term is yn. So 9 times yn. So yn already we are having. So n into 3 power n is equals to the right hand side, which is 3 to the power n. This is what I did putting the trial solution into the given equation. Now, as I told you, we are supposed to simplify this term as per the right hand side of the equation. So right hand side is 3 power n. So what I supposed to do? Take 3 power n common from all the term. If I take 3 power n common, what left? So 3 power n is out. So a into n plus 2. And from this power, it is n plus 2. 3 power n is outside. So 3 power 2 left, which is 9. 3 power 2 is 9 minus from this term 9an is equals to 3 power n. Okay. So let us further simplify the inside term. So 3 power n into this multiplication will make it as 9a into n. Then 9 to 18a plus 18 times a. I'm simply multiplying this term inside minus 9 of an is equals to 3 to the power n is equals to 3 to the power n. So this term got cancelled by this. What left? 18n. So what I get? 3 power n into 18 times n, not n, a, is equals to 3 power n. Now what else? The same as we did in the last example, comparing the coefficient of 3 power n. Comparing the coefficient of 3 power n. What comes on the left side? The coefficient of 3 power n is 18 times a, and the right hand side the coefficient is 1. It gives you the value of a as 1 upon 18. The value of undetermined coefficient that we are searching comes out as 1 upon 18. So what next? What we did as in the last example, put this a in second. So the last step, we are supposed to put a in equation number second. So when we put this a in equation number second, what we get? We will get the final particular solution. And how much it comes out, let us see. When I put a in second, your y and p particular solution is equals to, in place of a, it is 1 upon 18 into n into 3 to the power n. This is the final particular solution for the example number 2. Understood? So we discussed two examples of the case beta power n. One where roots are not repeated. Second, where roots are repeated in the nature. Now let us talk about the example number 3. In example number 3, what it is given? It is given polynomial. Polynomial of degree 2. It is given as n square. Okay. So we'll write the trial solution as for n square. So example number 2 now. So the example number 2 is given as yn plus 2 minus yn plus 1, yn plus 2 minus yn plus 1, and minus 2yn equals to n square, minus twice of yn is equals to n square. Okay. So let us write the trial solution. So as it is polynomial of degree 2, let the trial solution yn for the given equation is n square, means second degree polynomial. So p0 plus p1n plus p2n square. This is your trial solution. And you can check it. It is independent from your trial homogeneous solution. You can check it by yourself. So let this is be the trial solution of trial solution of equation number 1. Make it as 2. Now what is our task? Our task is what? To find P0, P1 and P2 by substituting this yn into the given equation. Okay. So put yn in first. This yn we are supposed to put in first. The first term is yn plus 2. So in place of n, put n plus 2 in your trial solution. What we will get? P0 plus P1 into n plus 2 plus P2 into n plus 2 whole square. Simply replacing n by n plus 2 minus yn plus 1. So now wherever you find n, replace it by n plus 1 in yn. So this is how we obtained yn plus 1. The last term is twice of yn. So minus twice of, in place of yn, it is p0 plus p1n plus p2n square. And it is given as equal to n square. What I did, I simply substitute all yn into the given equation. Now what is the next thing? The next thing is what? We are supposed to simplify this equation and try to find the coefficient P0, P1 and P2. As already discussed, your left hand side simplification should be as your right hand side in terms. So right hand side is n square. N square means degree 2 polynomial. If we arrange a degree 2 polynomial, how it can be arranged? First, the constant term, then the coefficient of n, then the coefficient of n square. This is how it should be arranged. Okay. So we will do it in the same manner. First all the constant, then the coefficient of n, then the coefficient of n square. Either you can do it directly or firstly open the whole square and simplify the term. It's up to you. So let us see what we will get. This is your P0 plus taking P1 inside. Okay. So P1 times n plus twice of P1 plus this is n plus 2 whole square. So first open the whole square and multiply by n square. So a plus b whole square. A square means n square and I am parallelly multiplying it by P2 plus B square, that is 4 times P2 plus 2AB. So 2 into 2, 4, 4n times P2. So what I did over here, I simply opened the whole square and multiplied it by P2 minus the next term is I'm taking this minus parallelly inside. So minus P0 minus take P1 inside. So P1 times n minus P1. Now over here I am having n plus 1 whole square. So open n plus 1 whole square and take P2 inside. A square means n square. So minus n square times P2 plus b square, so minus P2 plus 2ab, so minus 2n times P2. So this is what the second term we are having. Moving to the third term, minus, take 2 inside. So minus, it comes out as minus twice of P0 minus twice of P1n minus twice of P2n square is equal to n square. Now let us see the term which got cancelled out. Is there any term which is cancelling? So this is P2. So n square P2, n square P2 get cancelled out from here. Is there any other term which is cancelling? Let us see. 4n times P2 is there. Is there anywhere 4n times P2? So 4n times P2. 4n times P2. This is only there. 2n times P2. This is there 2n times P2. Okay, let us arrange the term if nothing. P0 also get cancelled. P1n. P1n. Is there any other term who got cancelled? 2P1. This is your P1. This is 4 times P2. Okay, let us write the leftover term in the order. In the order means firstly we will write all the constant term, then we'll write all the term which do not have which is having n, then the term which is having n square. That is the three kind of term: constant, coefficient of n, and coefficient of n square. First, let us list all the constant. So this is 2p1, so purely constant term. 4p2 is also constant, so plus 4 times p2. And other constant, yes, this is constant minus p1. Is there any other constant? Yes, minus P2, minus twice of P0, minus twice of P0. And so these are the constant term that we get it. Now the coefficients of n. So the term which is having n with them. So this is the term which is having n. N is common, so 4 times P2. And this is the term having n, so minus 2 times P2. And this is the term having n, minus twice of P1. So these are the term which is having n. Now the term which is having n square. So let us see n square terms. Only one term left with n square. So minus twice of P2 is equals to n square. Okay, let us see what happened next. So this is 2p1, this is minus p1. So 2p1 minus p1 is p1 only. This is 4p2 minus p2. So my plus 3p2 and minus twice of p0. This is what comes with the constant, and the plus with n what left? 4p2 minus 2p2. So 2p2 only and minus 2p1. And the last term is n square into minus of twice of p2. N square of minus of twice of p2, and it is equals to what? N square. So this is what the final simplification we get for this problem. Now what next? We will compare the coefficient on both the sides. Compare the coefficient on both the side to obtain the constant. So if you see the left hand side, these are the constant term. What is constant on right side? No constant. So this is equal to 0. So P1 plus 3P2 minus twice of P0 equal to 0. Equal to 0. Equation number 1. This is the coefficient of n. There is no coefficient of n on the right side. So second equation will be twice of P2 minus twice of P1 equal to 0. The last equation, it is given minus 2P2 is the coefficient of n square. Right hand side, coefficient of n square is 1. So minus twice of P2 is equals to how much? 1. So this equation gives you the value of P2, which is minus 1 upon 2. When we started with the trial solution, our aim to evaluate these undetermined coefficient, which is P0, P1, and P2. Obtain P2. If we put this P2 in this equation, then what we will get? We will get P1 also. From this equation, P1 is equals to P2. Okay. So P1 is also comes out as minus half. So when I put P2 in this equation, I will obtain P1 as minus half also. Now P0 is still left. So P1, P2, put it in the first equation. So if in this equation I put P1, P2, let us see what will happen. P1 is minus half plus 3 times P2. So minus into 3 by 2 and then minus twice of P0 is equal to 0. So how much it will comes out? Minus half minus 3 by 2 is minus 4 by 2, which is minus 2. So minus 2 minus twice of P0 comes out as 0. So it will gives you P0 equals to 1. So we obtained all the coefficient, which is P0, P1, and P2. What else? What last? Put them in second. Put them, that put the value of P0, your P1, your P2 in equation number 2. So final step, your particular solution y and p comes out as, the first term is P0, so P0 is 1 plus P1, so minus 1 upon 2 into n. The last term plus P2 n square, so minus 1 upon 2 times n square. So this is what your final particular solution for the given recurrence relation. I hope you understand the procedure. The procedure says that the first thing is what, write the trial solution as per the right hand side, put this trial solution into the given equation, compare the coefficient as per the right hand side. Do remember when simplifying, your simplification should be as per the right hand side of the equation. Once comparison done, you will get all the coefficient, undetermined coefficient, and these undetermined coefficient when substituted in your trial solution gives your final particular solution. Okay, so this is how we get the question number 3. There's one more question if we see. The last question is what? Yn plus 2 plus yn equals to 4 power n plus n. The combination of the two cases. The combination of the two cases, let me write it on the next slide. It is yn plus 2, yn plus 2 plus yn plus y times n is equals to 4 power n plus n. 4 power n plus n. Okay. So what will be the trial solution? The trial solution will be written as per the Fn. Fn is the combination of these two cases. So let the trial solution of the given equation is an equals to for beta power n, a into 4 power n. बीच में plus, like between them is plus, so put plus. Now n is the degree 1 polynomial. So for degree 1 polynomial, it is p0 plus p1n. So this is your trial solution. Now what next? We are supposed to put this trial solution into the given equation, and then simplify in such a manner that we will obtain the undetermined coefficient. So what is undetermined over here? We are supposed to find A, we are supposed to find P0, we are supposed to find Pn. When we substitute these values in the given equation, the simplification should be as per your right hand side. That means there is a one term where 4 power n is common. There is one term which will be compared with the first term, which will be compared with the first term of what? This first term. Then we will have all the constant compared with P0, then all the term which is having n with them compared with this term. So this is how the simplification can be done. For 4n, this is the comparison. For these two terms, we'll do comparison like this. Constant is 0 over here. So this term, after comparison, will make it 0. For this term, we'll make it 1. Compare, find the coefficient, put them back in equation number 2 to get the final particular solution for the given recurrence relation. For the given recurrence relation. So this is how we can find the trial solution of the given recurrence relation by using the concept of undetermined coefficient. It's simply that you need to understand the nature of your Fn, and on that basis, you are supposed to decide a trial solution, convert it into final particular solution by finding undetermined coefficient. I hope you understand these three examples suggested to solve the last example. Okay, so that's all for this session. Thank you for attending it. Now let us close this.